Okay, now in this example, we're looking at two capacitors that are connected with each other in parallel. So let me first draw you a picture of that. So we have a capacitor here, and its top plate is connected to another capacitor here, right? And their bottom plates are connected to one another. And then this combination, you can think of it, is then connected to a battery over here with a particular voltage given. So that voltage is the voltage, you can think of it, I guess, right here is A, and this is point B. So that voltage AB is given as 18 volts. And then we're going to call this capacitor C1 and this capacitor C2. Okay, so in the first part, we would like to find the equivalent capacitance. We'll call that part A. What is the equivalent capacitance in parallel? And if you recall earlier in our notes, we derived this formula. The equivalent capacitance in parallel is simply just adding the capacitances. So really what we're going to do is just simply add capacitor 1 and capacitor 2, their capacitances. So you just simply take the 6 microfarads capacitance plus the 3 microfarad capacitance and gets you 9 microfarads of capacitance. That's for part A. Pretty straightforward. When you have capacitors in parallel, you just simply add the capacitances together. Part B, we're asked to find the charge on each plate. So there's going to be some charge that will build up on here. You can think of there's a couple of positives here, and a couple of negatives here, and maybe a couple of less positives here, and a couple of less negatives in here. But their charges are not the same, right? But what we do know is that their voltages are the same. So the voltage of AB is the same as the voltage drop across capacitor 1 and the voltage drop across capacitor 2. So they are all in parallel with each other. So voltage, and this is, by the way, equal to 18 volts. So we now know that they're both 18 volts across this guy, 18 volts across this one, which is obviously in parallel with the voltage across the battery. Okay, and if you recall, capacitance equals charge divided by voltage. So if we want to find the charge, we can take the capacitance and multiply by the voltage. Okay, so charge on the capacitor 1 will be equal to capacitance 1 multiplied by its voltage. So this is going to be 6 microfarads multiplied by a voltage of 18 volts. Similarly, we have charge for capacitor 2 would be C2 times delta V2, and it'll be 3 microfarads multiplied by 18 volts. Okay, and so then we just have to multiply them out. And so the capacitor with the larger capacitance will have 108 in microcoulombs, and the one with the smaller capacitance will be 54 microcoulombs. Okay, and I guess you could compare that, I suppose. You could say, well, what is the total charge? Total charge is Q1 plus Q2. Let's just kind of double check that. It's going to be 108 microcoulombs plus 54 microcoulombs. So that gives you 162 microcoulombs of charge. That's the total charge. And if we were to compare that with the charge of the entire capacitance, we could just take the C equivalent of it in parallel, right? And multiply that by the total voltage. So if we take 9 microfarads and multiply by 18 volts, I get an answer of 162 microcoulombs. So yeah, it checks out because, well, the charge of 1 and the charge of 2 add up to the total charge if you have it replaced with just one big capacitor, and it would have a charge of 162 microcoulombs as well. Okay, that's it for example 11b.